Hello friends, welcome to Sohitham AI. Every day we hear the word artificial intelligence, but do you know where it really began? Today we will travel through time to discover who created AI, how it started, and how it suddenly changed our world. Let's begin our journey to the mind of machines. Before we understand how AI works, let's first meet the legends who made this dream real. Every field has pioneers, and for artificial intelligence, there are three legendary scientists who brought AI back to life when many people thought it was impossible. Let's meet them one by one. First, Jan LeCun. He taught machines how to see, thanks to his work in deep learning. With this, AI can recognize faces, objects, and images like the same technology used in phones, cameras, self-driving cars. Next, Geoffrey Hinton. Often he called the father of neural networks. He showed the world how computers can learn in a way inspired by the human brain. Almost every modern AI system today is built on his ideas. And then Yeshua Benju. He helped make deep learning faster, smarter, and more reliable. His research made it possible to train very large AI models using massive amounts of data. Together, these three scientists sparked the modern AI revolution. That's why they are known as the godfathers of artificial intelligence. For their groundbreaking contributions, they received the 2018 Turing Award, often called the Nobel Prize of Computing. But much before their time, there was one man who laid the very foundation of artificial intelligence. He is Alan Turing. Alan Turing was a brilliant British mathematician and a legendary codebreaker. During World War II, he built a machine that decoded the German Enigma code, saving millions of lives and changing the course of history. But his greatest contribution came in 1950 when he asked a simple yet powerful question: can machines think? To explore this idea, he designed a test. If a person has a conversation and cannot tell whether the other side is a human or a machine, then the machine can be considered as intelligent. This idea became known as the Turing test, one of the earliest foundations of artificial intelligence. Even today, AI tools like ChatGPT, Microsoft Copilot, Gemini are getting closer to passing this test, but not completely yet. After this idea, AI did not grow overnight. Its progress happened slowly, step by step. It grew gradually for decades, and then one day it went everywhere. That's why we say gradually, then suddenly. On this slide, you can see a list of important milestones. Each milestone marks a moment when AI took a major step forward. Let's go through them one by one. Let's start with the very first milestone, the founding moment of artificial intelligence. Our journey begins in 1956 at Dartmouth Conference. This was the first time artificial intelligence was officially declared as a new scientific field. Let's move to second milestone. In 1997, IBM's supercomputer Deep Blue defeated world chess champion Garry Kasparov. For the first time, a machine outsmarted a human grandmaster. Let's move to third milestone. Our journey now jumps to 2011. In this year, IBM's AI system called Watson appeared on the popular quiz show Jeopardy! Watson competed against the best human players and won. It answered complex questions and responded with incredible speed and accuracy. This moment showed the world that AI could understand language, process information quickly, and perform well in real-world situations. Let's talk about fourth milestone. On this slide, we see three different pictures created by AI. Let's start with the first image. In 2018, for the first time, an artwork created by artificial intelligence was sold at famous auction at Christie's. An AI-generated painting called Edmond de Bellamy was sold for $432,500. This shocked artists and people all over the world. But the story didn't stop there. Now look at the middle image. This AI created artwork was inspired by the famous painting girl with a pearl earring. For a short time, it even replaced the real painting. Many visitors did not realize they were looking at an AI created image. This made people think, if we can't tell the difference, what does art really mean? Now let's look at the third image. In 2023, a photographer named Boris Elson won the Sony World Photography Award using an AI generated image. But he surprised to everyone. He refused the award, saying that AI images and human photography should not be treated as the same. Next, in 2022, ChatGPT was launched and it changed AI forever. In just 2 months, it reached 100 million users, the fastest growth of any consumer product in history. This was a turning point. For the first time, artificial intelligence became accessible to everyone, from students to office employees to CEOs and business leaders. Everyone suddenly had an intelligent assistant at their fingerprints. By 2026, AI had gone fully mainstream. Unlike the supercomputers of the 90s, owned by only few institutions. But today's AI lives in the cloud and is available to anyone with an internet connection. ChatGPT didn't just become popular, it opened the door to new generation of AI for the entire world. Now that we have seen how AI transformed the world, let's understand what artificial intelligence actually is. What exactly is artificial intelligence? The Oxford Dictionary defines AI as the capacity of computers or other machines to show intelligent behavior. In simple words, AI is the ability of machines to perform tasks that normally requires human intelligence, like understanding language, recognizing images, or making decisions. But for machines to act as intelligent, three things must come together. One, advanced algorithms. These are the instructions or rules that tell computers what to do. Second, computing power. This is the hardware power that helps machines process information and learn. And third, massive data. This is the fuel, the information that teaches machines what to learn and how to improve. When all three comes together, we get the AI systems we use today. To understand this better, let's compare AI with the traditional computer program. In traditional programming, humans write very clear instructions like if this happens, then do that. The computer does not think, it simply follows the rules exactly as written. This works very well in controlled situations like calculators, billing systems, software applications, where every rule is clearly defined. Now, let's compare this with AI systems. In artificial intelligence, we don't give the rules. Instead, we give data. And from that data, the system learns patterns on its own. The biggest advantage of AI is that it can continuously learn from experience and improving itself over time and adapting to new situations. For example, an AI system trained on millions of medical scans can learn to detect tumors without fixed step-by-step rules. So the key difference is simple. Traditional programming follows instructions. AI learns from data. If AI learns from data, the next question is, how does this learning actually happen? How AI systems learn? AI systems learn from data, just like humans learn from experience. The more data an AI system sees, the better it becomes at making predictions recognizing patterns and taking decisions, just like a child improves with practice. This learning mainly happens in two major ways. Let's understand these two learning approaches. The first approach is machine learning, where system learns patterns from data and gradually improve performance over time. The second approach is deep learning, a more advanced method that uses large neural networks inspired by the human brain. Deep learning handles very complex tasks like image recognition, speech understanding, and language generation. So whether it's recognizing faces, understanding speech, or generating text, everything comes back to one core idea, that is learning from data. But learning alone is not enough. The system must also be trained properly. There are three main ways AI systems are trained. First, supervised learning. Here, the AI learns from labeled data. That means the system already knows the correct answer. It learns by comparing its predictions with the actual correct output and improves over time. For example, if we give images labeled as cats and dogs, the AI learns how to recognize the differences between them. Next, unsupervised learning. Here, the data is not labeled. The AI is not told what is right or wrong. Instead, it explores the data on its own and finds hidden patterns or relationships. For example, it can group similar customers or detect unusual behavior. Finally, reinforcement learning. This is learning through trial and error. The AI performs an action, then receives a reward or a penalty. Based on that feedback, it improves its decisions over time. This method is commonly used in robotics, gaming, self-driving cars, and decision-making systems. So remember, supervised learning learns from answers. Unsupervised learning finds patterns. Reinforcement learning learns from feedback. Now that we have understand how AI is trained, the next critical ingredient we must talk about is data, the fuel that powers artificial intelligence. You may hear this phrase before, data is the new oil, but actually in today's world data is even more powerful than oil. And just like oil powers engines, data powers artificial intelligence. Data fuels modern AI algorithms. It allows machines to learn, find hidden relationships, and make informed predictions. The more data an AI system gets, the smarter and more accurate it becomes. As of recent estimates, the world is generating over 180 to 200 range of zettabytes of data every year. This massive explosion of data is one of the biggest reasons why AI has grown so rapidly in recent years. But where is all this data coming from? Let's look at the key forces behind this explosion. Data explosion is driven by three major forces. First, connected devices. Around the world, there are more than 30 billion connected devices, which are more than 3 times global population. Many of these are IoT devices, smartphones, smart home appliances, and connected cars are constantly collecting and sending data. The second driver is social media. Every single day, over 100 billion messages are exchanged on WhatsApp alone, and video platforms like YouTube, Instagram, TikTok generating massive amounts of video data. The third driver is new technologies. Sensors in smart cities, energy grids, traffic systems, and public infrastructure generate massive amounts of data about how people live, move, and behave. When you combine connected devices, social media, and technologies, you get unstoppable data explosion. Now let's see how this massive data actually powers a real AI application. Big data is what transforms AI from just an idea into a powerful real-world technology. First, training data. AI needs large amounts of data to learn patterns accurately. This is especially important for complex tasks like self-driving cars, navigations, and advanced robotics. Next, model performance. When AI has access to big data, it becomes more robust and reliable. For example, in healthcare, AI can analyze large volume of patients' data to support better diagnosis and treatment decisions. Third, predictive analytics. Businesses use AI to forecast trends, understand customer behavior, and anticipate market changes. This helps them make smart decisions. Fourth, personalization. AI understands individual preferences and delivers personalized recommendations. For example, shopping apps, video platforms, and social media feeds. Next, natural language processing. Chatbots and virtual assistants use large amounts of text data to understand and generate human-like language. Finally, real-time decisions. AI can process data instantly to detect fraud, identify unusual activities, and provide immediate recommendations. So, big data helps AI learn better, predict smarter, and respond faster. But handling this much data is not easy. So, the next question is, where is all this data stored and managed? To manage data effectively, organizations use three main systems. First, data warehouse. A data warehouse stores structured data in highly organized format. Think of it like a digital filing cabinet. Everything is neatly arranged and easy to find. It is commonly used for financial records, sales data, and transaction systems. Next, data lake. A data lake stores all types of data, structured, semi-structured, and unstructured. This includes images, videos, reviews, and even raw sensor data. Unlike a warehouse, the data here is stored in original form. Finally, data lakehouse. A lakehouse combines the best of both worlds, the structure of data warehouse and the flexibility of data lake. This makes it ideal for modern analytics and AI-driven applications. So remember, data warehouse organizes data lakes collect everything, data lakehouse brings both together. But storing data is only part of the story. To process all this data, AI needs massive computing power. So far, we have talked about data, but data alone is not enough. To turn data into intelligence, AI needs computing power. Modern AI systems require massive computation and sometimes thousands of GPUs working together. For example, Microsoft built a supercomputer with around 10,000 GPUs. Google's TPU chips can perform up to 400 trillion calculations per second. And interestingly, most of the world's chips are made by just two companies, TSMC and Samsung. Why does this matter? Because of this power, AI can learn faster, handle huge data, and solve complex problems. So remember, data is the fuel, algorithms are the brain, computing power is the engine. Now let's move to the bigger picture, the different types of AI. Artificial intelligence is a multi-use technology used across many industries. Because AI systems are so diverse, we classify them in three key ways: by learning method, by capability, and by functionality. As we already discussed, AI learns mainly through two approaches. First, machine learning. Here, systems learn patterns from data using methods like supervised, unsupervised, and reinforcement learning. Second, deep learning. This is a more advanced approach that uses deep neural networks inspired by the human brain to solve complex problems. We will explore both machine learning and deep learning in more details later. Now that we have understood how AI learns, let's classify AI based on how powerful it is. There are three levels of AI capability. First, ANI, we call it as narrow AI. This is the AI we use today. It is designed to perform one specific task. For example, ChatGPT, Google Gemini. Next, AGI, Artificial General Intelligence. This is AI that can think and learn like a human. It can perform any intellectual task. However, it is not fully developed yet. It's still a future goal. Finally, ASI, Artificial Superintelligence. This is beyond human intelligence. It's still theoretical and does not exist today. Now let's see what AI actually does in real life. AI systems can also be classified based on what they do. First, expert system. An expert system is a computer program that behaves like a human expert. It uses stored knowledge and rules to give advice or make decisions in a specific area. For example, a doctor suggesting treatment, a financial advisor recommending investment, or a travel planner suggesting trips. Next, predictive AI. This type of AI analyzes past data to predict future outcomes or trends. For example, forecasting sales, detecting risk, or predicting customer behavior. Finally, generative AI. This type of AI creates new content such as text, images, code, or music. We will explore generative AI in more details in next video. So, expert system gives advice. Predictive AI forecasts the future. Generative AI creates new content. As AI becomes more powerful, using it responsibly becomes even more important. So now let's understand the 6 key ethical principles of AI. Navigating the complex world of artificial intelligence requires a strong ethical foundation. To ensure that AI benefits humanity and does not cause harm, experts, researchers, and organizations around the world have defined 6 core ethical principles for responsible AI. These principles guide how AI systems should be designed, developed, and deployed into the real world. They help ensure that AI remains safe, fair, transparent, and aligned with human values. Let's start with the first key principle, fairness and non discrimination. AI learns from data, and the data comes from humans. So, if the data has bias, AI can repeat that bias. For example, if past hiring data preferred men, AI might unfairly reject women candidates. That's why reducing bias is critical. AI should treat everyone equally, without discrimination based on gender, caste, religion, or background. And fairness is not a one time effort. AI systems must be continuously monitored and improved. Responsible AI means treating everyone fairly always. But fairness alone is not enough. People also need to understand how AI makes decisions. So next, let's look at transparency. Now let's talk about the next principle, transparency. Transparency means AI systems should not work like hidden black boxes. People should be able to understand how the system works and why it makes a particular decision. For example, if an AI system rejects a loan or job application, people should be able to ask why this happened. That's why responsible AI needs a clear documentation and simple explanation. In simple terms, transparency means opening the black box, understanding the data, logic, and how decisions are made. Because when people understand AI, they begin to trust it. But AI system depends on heavily on data, and very often the data is personal. So protecting privacy is not optional, it is essential. Let's discuss privacy and data protection. Now let's discuss privacy and data protection. Privacy means AI system must respect people's personal information and their rights. Responsible AI should collect only the data that is truly necessary, nothing extra. This helps reduce risk and protects sensitive information. At the same time, personal data must be stored securely and prevent unauthorized access or misuse. Users should also have full control over their data. They should clearly understand what data is being collected, how it is used, and why it is needed. And importantly, people should have the right to delete their data whenever they choose, because AI should never compromise privacy in the name of innovation. Protecting data is critical, but when AI system make mistakes, someone must be responsible. So, next, let's look at accountability and governance. Now let's talk about accountability and governance. Accountability means there should always human responsibility behind every AI system. If an AI system makes a mistake or cause harm, organizations must clearly know who is responsible. That's why companies need dedicated AI oversight people responsible for ethics, monitoring, and compliance. AI decisions should always be traceable. We should be able to understand how and why a decision was made. And since technology keeps changing, AI systems must be reviewed regularly to ensure they remain ethical and reliable. Because no AI system is perfect. When mistakes happen, organizations must be ready to fix the issue and support affected users. In simple terms, AI should never unaccountable. Responsibility must always remain with humans. Accountability creates responsibility, but safety creates trust. So next, let's understand how AI systems keep safe and reliable. Now let's talk about safety and reliability. Safety and reliability mean AI systems should behave correctly and consistently, even in unexpected situations. Before deployment, AI systems must be carefully tested to identify errors, risks, or unwanted behavior. And monitoring should continue even after deployment because AI systems can change over time. Responsible AI also includes fail-safe controls and allowing humans to pass, correct, or step the system if something goes wrong. And finally, after fairness, transparency, privacy, accountability, and safety, we come to the most human-centered principle, human autonomy and well-being. Now let's discuss the final principle, human autonomy and well-being. This principle ensures that AI supports people rather than controlling them. AI should assist human decision making, not replace human judgment, especially in critical areas like healthcare, law, or hearing. That's why important decisions should always include human oversight. People should also have the freedom to choose human alternatives instead of fully AI driven process. And most importantly, AI should improve quality of life without causing harm, dependency, or manipulation. Because responsible AI is not just about machines, it's about people. So, as we have seen, artificial intelligence is not just about technology, it's about responsibility, it's about ethics, and most importantly, it's about people. Thank you for joining me on this journey through artificial intelligence. I hope this video helped you not only understand how AI works, but also why responsible AI truly matters. If you found this video useful, please like it, share it with others, and subscribe for more AI videos.